At their closest point, Russia and Alaska are separated by only 86 kilometers across the Bering Strait. On a map, it seems like the perfect place to connect Asia and North America with a bridge or tunnel. If such a crossing existed, it could create one of the longest land transportation routes in the world. So why hasn't it been built? The biggest obstacle isn't the distance, it's nature. The Bering Strait is one of the harshest environments on Earth. During winter, massive sheets of sea ice drift across the narrow channel. These aren't thin layers of frozen water but enormous moving ice fields capable of exerting tremendous pressure on anything in their path. A conventional bridge would have to withstand constant impacts from millions of tons of moving ice year after year. Building below the surface isn't much easier. Beneath the seabed lies submarine permafrost, ground that has remained frozen since the last ice age. Drilling through this frozen layer generates heat, which can destabilize the soil and create major engineering risks. Constructing a long tunnel in such conditions would require technology beyond what has been used on existing underwater tunnels. The region is also located near one of the world's most active seismic zones. Earthquakes regularly occur around the northern Pacific, meaning any permanent structure must be designed to survive powerful ground movements while operating safely for decades. Even if engineers solve these technical problems, another challenge remains: infrastructure. The areas surrounding the Bering Strait are among the most remote places on the planet. There are very few roads, towns, or major transportation networks connecting to either side of the proposed crossing. Building the bridge would only be the beginning. Thousands of kilometers of new highways, railways, and support facilities would also be required through frozen wilderness. Cost is another major factor. Experts estimate that a complete transportation corridor connecting Russia and Alaska would require investments reaching hundreds of billions, or even trillions, of dollars. Considering the limited population and relatively low traffic demand in the region, recovering such an investment would be extremely difficult. Over the past century, several ambitious proposals have been introduced, including giant bridges, underwater tunnels, and even international railway links. While many were technically fascinating, none advanced beyond the planning stage due to engineering, financial, environmental, and political challenges. Today, researchers continue exploring new technologies, including floating underwater tunnels and advanced transportation systems that could one day make such a crossing more practical. These futuristic designs aim to work with nature rather than fight against it. For now, however, the Bering Strait remains one of the few places on Earth where two continents nearly touch but remain permanently separated. It serves as a reminder that even with modern engineering, some natural barriers still demand patience, innovation, and extraordinary resources before they can be overcome. Create a cinematic, ultra-realistic documentary about the engineering challenge of building a bridge or tunnel across the Bering Strait between Russia and Alaska. Begin with breathtaking aerial drone shots of the Arctic Ocean, snow-covered mountains, frozen coastlines, and an animated world map highlighting the narrow 86-kilometer gap separating Asia and North America. Explain how this short distance has inspired engineers for over a century while remaining one of the world's greatest unfinished megaprojects. Show massive drifting Arctic ice fields, violent blizzards, powerful ocean currents, towering pressure ridges, and enormous floating ice masses colliding with anything in their path. Include detailed CGI cross-sections of submarine permafrost beneath the seabed, illustrating frozen ground from the Ice Age, drilling operations, tunnel construction challenges, and the effects of melting permafrost on foundations. Visualize tectonic plate boundaries, earthquake simulations, underwater geology, and seismic activity affecting the region. Display the extreme remoteness of eastern Siberia and western Alaska with vast tundra, glaciers, frozen rivers, isolated villages, wildlife, and almost non-existent road networks. Show engineers surveying the landscape using helicopters, drones, satellites, drilling equipment, and advanced construction technology. Include realistic 3D animations of proposed bridge designs, underwater tunnels, artificial islands, suspension bridges, and futuristic floating submerged tunnels anchored below the surface, comparing their advantages and engineering limitations. Illustrate the enormous financial cost with animated infographics showing billions of dollars, logistics, transportation routes, construction materials, maintenance, and the difficulty of connecting thousands of kilometers of new highways and railways across remote Arctic terrain. End with inspiring cinematic sunrise and sunset shots over the Bering Strait, symbolizing the balance between human ambition and the unstoppable power of nature. Maintain a serious, educational, and visually spectacular tone throughout. Style: National Geographic, BBC Earth, Discovery Channel, IMAX documentary, ultra-realistic CGI, photorealistic environments, cinematic drone footage, 4K HDR, volumetric lighting, realistic water physics, engineering visualization, dramatic orchestral soundtrack, highly detailed textures, epic scale, professional documentary filmmaking, visually immersive, scientifically accurate.